Hello and welcome to my first person character controller tutorial for Unity. So I'm going to go ahead and create my character first of all. My starting point here is going to be a 3D object cylinder. Whenever I zoom in on this cylinder that I've just made, you'll notice that it's kind of secretly just a capsule because of the way that the collider works. So I've got our cylinder. Technically, if we turn off the mesh renderer, we can see our capsule collider here. It has these rounded edges. I'll turn back the mesh render back on so we can see the capsule. So we can see the cylinder for now. I'm then going to right click on this and create an empty object. This is going to determine the bottom of our character. So I'm going to position my camera and move this object down to the bottom of my character, making sure that it is a child of our cylinder. So now wherever the cylinder moves, the child will be at the bottom. And this is going to help us detect whether our character is on the ground or not. Therefore, I'm going to rename this ground check. And I'm going to rename the cylinder player parent just to make sure that we know that this is the player and this is also the parent object that other objects will be attached to. Speaking of things getting attached to it, I think I've deleted, my default camera here that you'll probably already have in your scene. So I'm going to get my camera back by just right clicking here and making a camera, but you will probably have a camera already in your scene. I'm going to make that a child of the parent as well. Instead of trying to position it exactly on top of my cylinder and make sure that all the values are correct, I'm just going to edit the values individually. So I can zero out the position, and that means it's now going to be right in the center of my cylinder. And while I'm here, I might as well zero out these rotations as well. So I can now move my camera relative to the parent. So I'm going to pull it up here to the top so that it's looking out at the world from the right perspective. So we've got our character set up. They're looking a little minimalist at the moment, just a cylinder with a camera on the top. But so let's get this to actually turn into a first-person character controller with some code. We're going to need, first of all, the camera to look around. So I'm going to create a new script for our camera to be able to look based on input. And to do that, I'm going to add and make a new script. There's two different ways, generally speaking, of making scripts. You can either right click here and go create, and then go to, where is our mono behavior? Here we go, mono behavior script, and that creates a new script. And then you can drag that script onto an object. The thing I quite like to do is add component, where we can add a component that we might need that Unity already has, or in this case, I'm going to go ahead and make a new one. So I'm going to type in FPS camera, and oops, let's spell that correctly. And this doesn't exist, so we can click new script to create that script. Whenever a window like this opens, sometimes people think that they should save their scripts somewhere else or save their stuff in other places, but this is actually, if you have a look, first person controller tutorial, that's the name of this project. This is the assets folder. This is this assets folder. It's super important that you just say, yep, that's fine. We're going to save it actually in our project. If we save it outside of our project, it's not going to go well. We won't be able to use it. So there it is. It's appeared, FPS camera, and here we've got it attached to our camera as well. So I'm going to double click to open this up in Visual Studio. So for us to be able to move the camera around, we're going to need to pull in our input. And it's a sort of a three-step process here for the new input system. The first thing we need to do is create a variable, which is going to be an input action variable. Now, input action doesn't exist within the context of our script yet. However, that's because we haven't imported the library. This quite often happens automatically, but we'll do it manually. We're going to type in using Unity Engine dot and then input system. Now input action is recognized as, oh, let's not forget our semicolon. It's now recognized as part of this library that we're importing. So in this case, we're going to create the variable. We're going to call it look action because this is going to be the input for looking around. We are going to then have to assign this to an action that already exists in the game. In our project here, we can see there is a look input action here already, so we can assign to our variable. So we're going to say our look action is equal to, and then we're going to call this static variable and then this method. And we're going to put look in here in between quotation marks to make sure that matches up here with the input that we're pulling from. So if we'd set up something else here in our actions, we would put something else in here for our string argument that we're passing through. So we've got our look action. The next thing we're going to do is actually store our input every frame, the new input from, in this case, our mouse moving around, or if we had a controller, our right stick. So I'm going to store this value as a vector2, being two values, and we'll call it mouse input for now. And we'll set this equal to our look action. And we'll pull this value in by reading it as a vector2 as well. So this will pull this information in. We're reading it as a vector2, and then we're storing it as a variable value vector2 here. Now, the reason it's a vector2 is because this is combined as two values, x and y, and you can see that this is a vector2 type of variable here in our action properties for look. So it's essentially combining, for example, A and D going left to right, and W and S going up and down. Those are two different values, from 0 to 1, or rather from -1 to 1, where -1, for example, might be going left, 1 it might be going right, and then that's our X value. So that's going to make up our vector2. This is important because we need to understand that X is left and right, Y is forwards and backwards. For this, which is our mouse input, so moving our mouse left and right, that's our x-axis input. Moving our mouse up and down, that's our y-axis. Things start to get a little abstract. Let's try to apply this movement to our actual object. Let's start by rotating the character. Rotating the character is a little different than rotating the camera. If we rotated the camera up and down, that's fine, and left and right is also fine. However, if we rotate the player up and down, you can see that the character will tilt. So actually, in most first-person games, you rotate the whole character on the y-axis, rotating around horizontally, but then you rotate individually the camera up and down, and you also do things like clamp this rotation. So let's first of all get a reference to the transform of the whole character. Oh, let's try and spell that correctly. There we go. Let's get the reference to the transform of the entire player parent so that we can rotate that around its axis. So we're going to do .rotate, and the axis we want to rotate it around is the vector 3.up, which is a constant up in the world. And we're going to rotate it by our mouse input. Oh, let's multiply those values. And again, so this is us rotating around our y-axis, so this will be the x-axis input. Now, before we just rotate around that axis, we're going to make our code not frame rate dependent by multiplying it by time.delta time. So there we've got our new input times equals time.delta time. So let's go ahead and see what happens when we rotate around. Before we do that, let's do one more thing before we test. We want to be able to control how fast this goes. So let's make a mouse sensitivity variable. Let's also multiply our rotation by that. And finally, when we save this code, so I'm going to do Control S or save, or I can go build and build solution. That's also a good one. And we go back to our code here. We've got two variables. We need to drag in our player parent into here, into the transform, and that set the mouse sensitivity to something like 15. So now we should be able to rotate around this axis from left to right, which is moving the whole parent. It's a little trickier to move the camera up and down because we have to keep track of that ourselves. We need to keep track of it ourselves because we want to clamp the rotation. What do I mean by clamp? Well, if we keep moving our mouse up, we don't want the camera to keep rotating and then sort of almost pull our neck muscles by looking up over our heads, and then we keep rotating round and round. That's just not what we want to happen at all. So let's go ahead and keep track of our own rotation with a float. So we're going to do public float vertical rotation. And we're going to keep adding to this every frame. So we're going to go here and add. Now, it would make sense to add plus equals our mouse input dot y. In this case, we're actually going to just do a little bit of a hack and do minus equals mouse input just dot y. And that's just because that will flip the value and rotate correctly when we move up. With the mouse, the rotation of the camera will actually move up as well. There's a few ways of inverting our input here, and this is one of them. So now we've got our vertical rotation that keeps compounding each frame. It keeps adding more and more to the same value, updating it. We can then use this value to actually rotate the camera. In this case, I'm going to, again, use a little fast track hack here of using the transform with a lower case, which accesses the transform of the object this script is attached to. So in this case, it's the camera itself. So we're now accessing the camera, so we can access not the position, but rather the local rotation. We can calculate a new rotation by using Quaternion Euler, since we just have 3 values we want to plug into this. So we've got the value of our vertical rotation, which will be our x value, and then do we want to rotate on the other axes? No, not at all. We just set those both to 0. So this Quaternion Euler is sort of forcibly setting the rotation over and over and over again every frame of our camera. Now, the whole point of this is that we can clamp this value. So we're going to do that before we set the rotation of the camera. We're going to set this equal to mathf dot clamp. So we're going to feed it the value of itself, but then we're going to tell it its minimum and maximum value. So its minimum value we'll say is minus 90, and its maximum value will be 90, which will clamp it. It will stop the camera from rotating further than 90 degrees in either up or down. So let's have a look and see if this worked. Save the code and run the game. We can sort of see our strange cylindrical body if we look down, which is perhaps not what we want. So I could go ahead and go to my parent and turn off the mesh render for now, in which case whenever we look down we'll not see anything. Some video games, they have a player character model for looking down. I remember, for example, Mirror's Edge has one of those, but most games just have, you look down and you don't see anything at all. So a lot of first-person games do, at least. Now, whenever we're moving our camera around, we can see the cursor. So we want to really lock that away. Just a quick line of code here to change the cursor state globally. This is something to look out for if you're ever coding a pause menu or something like that, where you need your cursor to come back again. This line of code, you may need something similar to it in your pause menu code to unlock it. So we could set this, for example, to none instead. Set our lock state to none. But we just want to, for now, lock our cursor away so that when we're running the game, we can't see the cursor as we're moving our camera around. I'm going to run this again and see what happens. So yeah, if I click, you can see my cursor disappears. I can look around up and down and so on. All right, so we've got our camera working. We just now need to do something which is slightly more complicated, which is actually move the player around, but it's the same principle. We need to get our input from the input system, and then we push that input to movement rather than rotation. For our character, we're going to use a character controller. So if I go to the character and type in character controller, it's a component that already exists in Unity that we can add. So I'm going to add this character controller, and essentially this is bunch of functionality that already exists in Unity for moving an object around. It's slightly different from something else that will also move objects around called a rigid body, which is a physics object. So it has a little bit more functionality, but it unfortunately doesn't use Unity's default physics system like a rigid body does. So we'll have to code our own physics essentially as well. But that does also allow us to control manually things like gravity a little easier. Most games have very unrealistic gravity, very sometimes called arcadey gravity. We'll really be pumping up the gravity for our player character here once we code it. So I'm going to add a new component to the player parent, and we're going to call this FBS movement. Doesn't really matter what we call these scripts, just so long as it's something that makes sense. So this is the code for moving. So I think first-person shooter movement makes sense, though maybe the shooter part doesn't make sense if this isn't going to be a shooter. FPS is just a classic acronym. So we've got our FPS movement here. Starting off, we're going to do the very similar thing to our look action, but in this case for a move action. I'm going to be lazy and copy paste these in. So we've got, for example, our input action variable. That's going to be for move action. We're going to want to assign it in the start method as well. So I'm going to copy paste this line of code. Instead of look action, it's the move action. And instead of finding action look, it's finding action move. Copy pasting is your best friend when you're a coder. Let's have a look. The next thing we want to do is something very similar here, where we've got mouse input so that we're reading in this input. But let's change this, of course, to move input. And we've got our move action as well. And it's still a vector 2, and we can confirm that by looking at our input system here and having a look at move. And yes, it's a vector 2 as well. So we're reading this in the same way. So we've got our movement input that we've got. We need to somehow push around our character controller with this input. So we can go ahead and reference the controller, but we need a variable for that first. So I'm going to make a character controller, and we'll call this controller. This variable had better be public so that we can access it and set it in Unity's inspector window. Now we've got our variable, we can use it here, and we're going to access a move method inside that character controller. And yeah, we can for now just directly stick our move input in there, though we're going to want to do something a little bit better. Oh, let's not create a new project. Let's try that again in the future. Okay, so we've got our code, we've got our input, and we're moving our character based on that input. Let's go ahead and minimize all of this. I'm going to go back to the player, drag in my character controller into this variable value, and see if we can just like move at all with this. Though it might be, oh, it's incredibly fast. Wow, I just like shot across the map, I'm pretty sure. Let's try that again. So I can look around, and I can move incredibly fast. There's a few problems with this. Oh, I'm moving up and down. Whoops. So yes, we've got X and Y in our move input, but X and Y means something slightly different in the 3D space. So we're going to have to do a bunch of calculations to actually change these values. So the first thing we're going to do is we're going to make our movement relative to our character in 3D. So we're going to change that vector 2 into a vector 3, and we'll call this new movement. And we'll set this equal to, again, a transform, which the lowercase will access the transform of the object this is attached to, which is just the player. We're going to grab the forward of the transform. So whatever direction the character is looking in, this will be forward from that direction, which is why we wanted to, by the way, rotate the character around on its actual axis here as well, so that our forward is actually correct. So we're going to grab the forward, we're going to multiply that by our movement input dot, let's see, a dot y, because our y is up and down in 2D land, but then that becomes forwards and backwards in 3D land. And then we're also going to want to add to that our dot right, but this time multiplied by x, which is our moving left and right. Our new movement is now the thing we're going to shunt into our character controller to see if it will move left and right and forwards and backwards now instead of up and down. And it should also hopefully be relative movement to where we're looking. So forwards and backwards. Okay, yeah, I'm going very fast, and left and right. It's important to test things as we go. I could just code the whole thing, do a whole bunch of code, make everything work, jumping, etc., and then test it. But by testing it as we go, one line at a time, a little more, we can make sure that we don't make any mistakes. And if we do make mistakes, we can identify potential problems there and then with that line of code that we just added. So we want to perhaps slow down our movement just the same way as in our camera. We wanted to control how fast the mouse sensitivity was. We're just going to do something very similar here. So I'm going to make a new public float, and we'll call this movement speed. Let's multiply our new movement by movement speed, and when we are finally adding it in to our controller, let's multiply it by time, by time dot delta time as well to make it frame rate independent. Let's set our speed to something like 12 and see how that goes. We can always change these values later. That's the whole point of them being variables. So we can move around now. This is looking good. Excellent. So we've got our movement. Time to add something that is the most complicated thing for sure, which is our gravity that we are coding ourselves. So much like rotation, where we keep track of it with a variable ourselves, we're going to have to keep track of our gravity with our own variable, our own vector 3. We're going to call this current gravity. That might be confusing. Let's call it current velocity instead, because gravity is going to be a unchanging variable that we'll set here as well, which is how much we are falling by. Well, how fast do we fall? And this is how fast we're currently falling. So we want to, every frame, just increase our falling. So we can take our current gravity velocity.y, and we're going to increase that plus equals our gravity. And we want to also make sure that this increase of how much we're falling, this increase of fall gravity, is also multiplied by time dot delta time. So it's frame rate independent. We want to combine both our movement and our gravity together. But as I was mentioning at the start of this video, we don't want to call this movement method more than once per frame. So we're going to create a new vector 3, which is called total movement, and simply combine both of these movements together. We're just going to add our current velocity to our new movement, and then we'll stick the total movement in as the variable to use to actually move the character, which will contain both of these two movements together. So altogether, we calculate a one big vector 3 to then move the character with. So we don't want to just keep moving the character down no matter what. We also want to make sure that we reset our velocity once we're on the ground. Otherwise, the velocity will just keep getting higher and higher and higher. And when we step off a ledge, we'll plummet super duper fast into the ground. So we want to check if we're on the ground or not. So how do we do that? Let's go ahead and use a couple of variables. We're going to, first of all, create a bool is grounded. This will be either true or false, depending on whether we're on the ground based on our calculations. We also need a reference to a transform, which will be our ground check location. This will be where we actually check if we're on the ground or not. And finally, we're going to want a little float, which will be our ground check distance. How far are we checking from our location, whether we're on the ground? This will make a little more sense if I save here and I go back to the ground check that we made, this empty game object at the bottom of the character. We're going to drag this in as the value for our ground check location. And we're going to set our ground check distance to about 0.4 will do. And essentially, I'm going to just check again here that this is at the bottom of our character, that this ground check here. we're going to in a moment check in code with a little circle, a little sphere at this position, and check to see if there's anything there. And if there is an object there, then that means that we're on the ground. And if there isn't, then we're not on the ground. So let's do that. We're going to do is grounded, is grind. Oh, let's change that to is grounded. Is grounded equals physics dot check sphere. And then it's going to want a whole bunch of values, this check sphere. So the first value it's going to want is where is it going to check the sphere, the position. We're going to set that to ground check location dot position. That's going to be where our empty is. What's the radius of this sphere? So I'm going to set that to the ground check distance. And finally, this last one is a layer mask, which we haven't made yet. So let's make that. This means that it's not just if anything is there in that sphere. For example, it could detect the player over and over again. That would be very awkward. We don't want the player to think they're standing on themselves. So let's go ahead and make a ground mask instead, which will then filter out what we're trying to detect for, in this case, just the ground. So is grounded is equal to these things. And then if we are on the ground, so we're going to make an if statement here and check if we're on the ground. And our current velocity dot y, which is our falling, is less than 0, aka we're not jumping in that moment. That will be relevant later. Then let's cap our current velocity to -2, so that we're not constantly accelerating our falling, even if we're on the ground. That would be not ideal. Why does it not like this? Oh, I don't have an equals, so it's equals -2. There we go. Let's save this out, and let's make sure our ground mask is set up correctly. So if I go to my player parent and scroll down, we can see we've got a ground mask here, which we want to be filtering for the ground. I have ground here already as an option. You won't. That's because I made a new layer. So if you go to layers here on any object, go to add layer, you can edit the layers. So you can add the ground layer here, like I have to randomly user layer 3. Then you're going to want to set your objects that you want to be able to actually jump on and land on to this layer. So for example, here I've got this cube, which is the ground. I'm going to set this layer to ground for that object. And then these objects here, you might think, do they need to be ground as well? If your character is going to want to be able to land on them and jump on them, then yes, absolutely. So I'm going to set these to ground as well. Then I'm going to go back to my player parent and change my layer mask variable to include ground. So it's only looking for ground when it does. So it's only looking for ground when we run this check sphere. So I'm going to save this, and let's have a look at our public variable. Where is it here? Is grounded, to see if it's correct or not. I always like making variables public, especially when I'm just prototyping stuff, so that I can look at them in the inspector window. So there it is grounded is ticked. And if we fall off, then is grounded becomes false for a moment. Now, looks like we're not falling through the air, so we're still just hovering midair, which is why is grounded is still false here. I think that's because I've forgotten to set my gravity here, so I'm going to set my gravity to -40, which is quite a high value. Realistic gravity might be, in a different tutorial series, set to like -9 or something, but I find that that's very, very floaty gravity, so I like a fast gravity that pulls you down very quickly. You can change these values as you want. So we fall off, and we land back on the ground. Okay. So next up, we're going to add jumping, and then that will be the final step for our code. So how do we add jumping? Well, we've already got our velocity that's constantly pulling us down to the ground. So all we need to do is add a new reference to an input, which will shoot us up into the air. So we're going to copy a bunch of stuff here. We're going to copy our input action and call this jump action. We're going to copy this line of code as well, change this to jump action, which is pulling from the input system. And yep, you guessed it, it's going to be jump instead of move. Let's just check our input system again to make sure that's correct. We've already got this set up by default. If it was our own system with more complex controls, this default jump wouldn't work. We'd need to set up our own action for something special, like a special move or an attack or something. Well, there is an attack here already, but you get the idea. In this case, jump already exists, and it's space bar on the keyboard, which is going to be fine. Now, it's not quite a vector 2, so we can't just pull our value in like this by reading value vector 2. Instead, we're going to set up an if statement here. And inside our if statement, we're going to go jump action dot is pressed, which is weirdly a method, so we have to use the 2 extra little brackets here. So this means that if we press the button jump, and it's the same frame as we've just pressed the button, this if statement will be true, and therefore we will do something. What do we want to do? Well, we want to make our character go up into the air. So we can essentially just set our y-axis value to some positive number, like, for example, 10. That would send us our character up into the air, because 10 is a positive value going up. And then subsequently our gravity would keep being added, and therefore we would come back down again. Instead of setting it just to 10, though, let's set it to a slightly more complex calculation based on what jump height we want to achieve. Weirdly, it's the square root of our jump height, which we haven't made yet. So let's go ahead and make a variable here. Call it float jump height. So now this can exist. It's our jump height multiplied by -2 multiplied by our gravity. Because the higher our gravity, the larger our jump height will need to be. Or sorry, let me try that again. It's a complex bit of math. The higher the gravity is, the more we're getting pulled down, the more our calculated value based on how high we want to jump will have to be. So this calculated square root should give us the value we need to set our velocity to based on the gravity increasing over time. It's a very complex math I won't go into right now, but the other thing we want to make sure is that we're actually on the ground. So we're going to add this to our if statement if we are is grounded, because we don't want to be able to just constantly jump over and over again while we're in midair. Let's go ahead and run this code and see if we're not able to jump. Let's also make sure that we're not able to jump in midair. Oh, before I run the code, of course, oops, don't save the changes. We didn't actually make any to the input system. We do need to actually set our ground height to something. I'm going to set this to 3. Otherwise, we'll try to jump to a ground height of a jump height of 0, which won't be very high at all. So we can jump up in the air. And hopefully you can see what I mean about having snappy gravity. We go up quite fast and then we come down quite fast as well. You can change how these values work if you wish, just by changing these variable values -40, which is quite high, and then our jump height, which determines how high our character jumps. So there we go. We've got looking around, we've got jumping, we've got our ground check. We can see here our is grounded is turning on and off correctly. And we've got our mask. This has been a very fast tutorial series. Feel free, links in the description, to have a look at Bracky's video, which describes a lot of stuff. A lot of the code here is complex. Hopefully you've been able to identify a whole bunch of different things that are going on, like variables, keeping track of values. The main thing is to get you up and running with a character controller. My advice for anyone that is trying to learn code is to look at something a little more simple than a character controller for actually learning the code from the ground up. So now you've got your character controller working, you could potentially mess around with other things like trigger boxes, audio getting played, lights switching on and off. That kind of stuff is a lot simpler and easier to understand, but you still have fundamentally a video game because you've got your character controller working now, which is why I was going quite quickly through this particular tutorial video.